Dear students, today we are going to discuss about some basic theorem which is required to discuss prior to start of numerical methods. Okay, so let us look how we can connect the plus 2 level mathematics up to numerical analysis and what is the pre-requirement theorems which already you know. This is only you have to revisit these theorems and which is very much useful for numerical method. So let us look the statement of these two theorem which is very important for this discussion, that is Rowe's theorem ki let f be a function such that f is continuous in closed interval ab and it is differentiable in open interval ab, and if f is equal to fb. The if f be a function such that it is continuous, it is derivable, and the value at a is equal to value at b. So this is the statement of Rowe's theorem. And intermediate, what is the intermediate value property? Intermediate value property say कि if f be any continuous function in closed interval a and b, and if k is any arbitrary number which is lying between fa and fb, then there exists a number e which is belongs between the open interval a to b such that fe is equal to k. So this is the statement of intermediate value property. Then in this connection, one more important theorem, that is mean value theorem. So the statement of mean value theorem which we must remember always, let f be a function such that f is continuous in closed interval ab, f is derivable in open interval ab, then there exists at least one e belongs in ab such that fb minus fa divided by b minus a is equal to f dash e. This is f dash, dash is here f dash e, where e is lying between a and b. So now let us look some few problem. Okay, how you can calculate the absolute error, relative error. If the problem is like this, okay, given that a is 10 plus minus 0.05, b is 0.0356 plus minus 0.0002, and c is 15300 plus minus 100, d is 62,000 plus minus 500, then find the maximum value of the absolute error when a plus b plus c plus d in this case, and in the case when c cube. So how you can, just let's learn this. Okay, we are given that a is equal to 10 plus minus 0.05, b is equal to 0.0356 plus minus 0.0002, and c is and d respectively, the values are written here. So you know कि absolute error means always the difference between true error, true value minus approximate value. So here all the values are having both the part, true value and plus minus. Plus minus means this may be the approximate value. Okay, so and this may be the true value. So now it means if a1, b1, c1 and d1 are the true values of a, b, c and d respectively, then we may write a1 plus b1 plus c1 plus d1 minus a plus b plus c plus d, which may be rewritten as a minus a plus b minus b plus c1 minus c, a1 minus a plus b1 minus b plus c1 minus c plus d1 minus d, which is algebraic identity is there if this is less than or equal to a1 minus a plus b1 minus b plus c1 minus c plus d1 minus d. Now you know this is, if you go for the difference, so difference क्या होगा कि this, you know the difference will be this 0.05 only. The difference means the error. तो error term क्या है, इतने ही है 0.05. okay, so this is the error everywhere. It does not matter कि पहले क्या लिखा है, ठीक है, उससे कोई मतलब नहीं. Error term is only this. Error means the true value minus approximate value. So this is only everywhere it is written plus minus means this is the error term already given. So you can write like this, and then after simplification you will get 600.0502, which is the required maximum value of the absolute error in a plus b plus c plus d. But what will be the in second case? So let us look the second case. For that further, if epsilon be the error in c, Then C is already, you look, concentrate on C only. C is 15300 plus minus 100. It means just if you go, because the function is cubic function, so you have to rearrange this C plus epsilon whole q minus C q, and this is A plus B whole q, you expand, then you will get this epsilon q plus 3 C epsilon square plus 3 C square epsilon. You know here the error term is 100. So this is 100 q plus 3 times this is C. C means 15300, and epsilon again means 100 square plus 315,300 whole square into 100. Now you can simplify this and you will get this result. Okay. So now you must remember whenever we deal such problem, then we always go for the expanded form. In expanded form, if you know you can take 10 power 10 outside, then you may be able to write in decimal position. That this will be the decimal position. It means this will be the value which is the required maximum value of the absolute error in this case. Okay. Now another problem which is very famous in the student domain, that is the value of pi. The pi is 22 by 7 is approximated as 3.14. Find the absolute error, relative error and relative percentage error. So how you can, absolute error 22 by 7 minus this is approximate. Approximate always we take 3.14. So how you can multiply this 7 here 3.14, then you will get 22 minus 21.98 by 7, and it is 0.02 by 7, and which is 0.002857. Similarly, the relative error will be 0.0009, and percentage multiplied by 100, you will get 0.09, okay, percent. So in this way you can find out the absolute error, relative error for any approximate numbers. Now this I want this you do the practice of these two problems. First problem is related to as we discussed. Second is find relative error in computation of x plus y, where for x is equal to 11.75 and y is equal to 7.23, having absolute error del x and del y are given. This is for your practice. I have given I want all the viewers, the students, you have to attempt 5 problem of your choice. Now sometime in the error analysis we must remember the Taylor's function of Taylor expansion, because we know that from intermediate calculus this part is very important. So if you look the series fx is equal to fa plus f dash a by factorial 1 x minus a plus f double dash a by factorial 2 and so on, then here you will find the value which is fka by n. So here this part is always the part of derivative, means order of derivative. So this is called the order of derivative, and the remainder term is here, that is fn plus 1 c divided by factorial n plus 1 into x minus a power n plus 1. So we must remember this may be also be useful for you. And these are the infinite series, you know, this is already all the known series of the school level, 1 plus x square plus x cube and so on. You may write this in the form of series, that is summation over k is equal to 0 to n x power k, or if you sum this series, then that is a divided by 1 minus common ratio, that is 1 over 1 minus x. Similarly, what is the kth term, nth term of exponential series? It is already there. And what is the expansion? So these are the some very, you can say, the fundamental series to discuss the mathematics, especially in numerical analysis. So you must remember very nicely what is their nth term and what is their expansion. So here in this PPT, I think sin x expression, what is the expansion? Say the summation term of the sin x, it is already written here, and how, what is the summation term of cosine x, and what is the expansion. So we should not forget all these fundamental infinite series. Similarly, to find the Taylor series for the various function fx, like the inverse trigonometric function, already if you concentrate and you know from one function you can deduce all other function also, like this if this series as we discussed in the previous PPT, q1 over 1 minus x, that is summation series term is this x power k, where k varies from 0 to infinity, then this is the series form. They start with known your Taylor series. And here, if you replace this minus x for x, then you will get 1 by 1 plus x. Here, if you substitute x square for x, then you will get this form. And after integration of this third series, you will get tan inverse x. So these all are connected, interconnected with each other. Now to find the Taylor series for the function gx is equal to x cube cosine hyperbolic root x, you can start from here. How? Just to check cosine hyperbolic x, this is this is the known series and derived from exponential series. Then start with from Taylor series or the exponential series, you can establish this, and then substitute under root x for x. Then you will get cosine hyperbolic root x. And if you want to establish this result, x cube cosine hyperbolic root x, then you have to multiply by x cube. Then in this way, these all the infinite series are interconnected with each other. If it is asked any time in numerical analysis, you have to change to approximate the error, especially in sine and cosine, if it is expressed in degree, then don't forget to convert into the radian. So how to convert it is already written here, like sine 30.01 degree. You may write like this, sine 30 degree plus 0.01 degree, and then you may write like this, sine 30 plus 0.01 multiplied by pi by 180. Pi by 180 means sine pi by 6 plus 0.01 pi by 180. So in this way you can do all desired calculation. Now here I want to introduce today what is the algebraic and transcendental equation, and especially today in this video I will try to discuss the bisection method. So just to solve the non-linear equation, and here we will discuss most useful method for finding the root of any equation having numerical coefficient. So non-linear equations, a polynomial of degree less than or equal to 4 can be solved by standard algebraic method, but no general method exists for finding the root of the equation of the type. These all are the non-linear equations. A log x plus bx is equal to c, or a into e power minus x plus b tan x is equal to 4 in terms of their coefficient. These equations are called transcendental equation, and we take help of the numerical method to solve such type of equation. So now in numerical analysis, if you go for the classification of the method, then you find that the method for finding the roots numerically may be classified into the following two categories. Direct method, and these methods requires no knowledge of an initial approximation and are used for solving polynomial. And second is iterative method. So there are many such methods. We shall discuss some of them here. Here successive approximation to the solution are used, and we begin with the first approximation and successively improve it till get result to our satisfaction. So that is the purpose of iterative method. Now if you look closely, then how you can find the solution of any polynomial, then just I want your concentration here. Let fx is equal to 0. If any polynomial you can graph like this, then you look this polynomial has the various spread over in various quadrant. So now you look at this part is f is always positive here. But if it is crosses, it meet this x-axis, means y is 0, means this is the solution. If this point, it means here you can say this is fc is equal to 0, and see the value c is lying between a and b. If this is b and then this point may be a, you can suppose this is the point a, or here you can suppose this is the point a. So it means this is this b is positive, but here this is negative. So y is equal to fx, then the value of x where the graph crosses the x-axis are the root of the given equation. This is called the root of the given equation because at these points y is 0, and therefore equation 1 is satisfied. If you go through all the numerical methods, so it is possible to solve the algebraic and transcendental equation, then these root finding methods spread over are divided into two categories. One method is called open methods. Open method include these three methods: iterative method, neutralization method, secant method. Another is called bracketing method. In bracketing method, bisection method, and Reveal position method. Today we are going to discuss bisection method. So bisection, like the name itself explained, okay, let us suppose we want to find a zero of a continuous function f. We start with an initial interval a naught and b naught, where f of a naught and f of b naught have opposite sign, which we check every time. Since f is continuous, then the graph of f will cross the x-axis. If it is continuous, then this must cross the x-axis. And if you concentrate here, then this always explains the complete picture of bisection method. The function crosses the x-axis between a and b. Here it is visible. If this is the point a and this is point b, then their middle point is a plus b by 2. Okay, so that is bisect. Every time we bisect, and we will go nearer to nearer of the root. And initial approximation you can take from a naught, that is only a guess where in between one positive and one negative values. Okay, so the bisection method systematically move the end point of the interval closer and closer together until we obtain an interval of arbitrary small weight that contains the root. We choose the midpoint, that is c naught, as discussed in the previous, that is a naught plus b naught by 2. It is, you can see here very easily. So if f of a naught and f of c naught have opposite sign, then the root lies in between a naught and c naught. If f of c naught and f of b naught have opposite sign, then the root lies in c naught and b naught. And if f of c naught is 0, then x is equal to c naught is a root. Okay, so if third happens, then the nothing to proceed, as c naught is the root in this case. If any one of a and b happen, then let a1 b1 be the interval representing a naught c naught or c naught b naught containing the root where f of a1 and f of b1 have opposite sign. Then the root lies between a2 and b2. Continue this process till the desired level of accuracy. So we will look in the numerical, that may be very easily to understood. Now this is the standard theorem you must remember before the bisection. So this theorem you must keep in your mind, but I want to discuss one numerical problem here. Find the root of the equation x cube minus 9x plus 1 is 0 by bisection method correct to three significant figure. How you can? So let fx is equal to this, then you can find out, you can test the value. F of 2 is minus, negative, but here f of 3 is positive. It means your root is lying between 2 and 3, because f of 2, f of 3 is less than 0. Thus a root are given, equation lies between 2 and 3. You can declare here, and you can assume a naught is, you can assume the middle point 3 plus 2 by 2 is, that is 2.5. So 2.5 you can assume the first root, and b naught is 3. Okay, so here it is advisable that you always do all the computation bisection method in a tabular form. So here you can take the 5 columns and multiple row. So like n, the value of n is 0, a naught is 2, b naught is 3, then xn plus 1, which is the bisection method, you have to bisect. So an plus bn by 2, that is 2.5. F of xn plus 1, you have to find out f of x1, means by putting here the value of 2.5, f of 2.5, you will get minus 5.8. Similarly for 1, 2.5, 3, 2.75 and minus 2.9. Okay. Similarly, 2.75 you can take here, and here you will get 3 and 2.88, and this is again the negative, means same status, minus 1.03. Next here, after putting 3, 2.88, 3, 2.94, and this is minus 0.05. Okay, so every time you look this varies. So if here you get the same sign, then you have to change the closure value. Okay, but here in this case, if you check the 2.94, this value is 3, and 2.97, the value is 0.47. First time this is positive. It means positive is shifted from 3 to 2.97. In the next value you will take, you will consider this value an, but you will change here now 2.97, because this is turned into the positive value. तो जो 3 का जो था उसकी शिफ्टिंग आपने कर लिया, तो 2.97, 2.955 and 0.21 again positive. Then again you will shift this 2.94, 2.955, 2.9475, and this value is 0.08. Similarly, 2.94, 2.9475, 2.9438, and 0.017. It means if you look the iteration number 7, 8, 9, then you got the result, because everywhere this is up to 3 significant figure. Here you can say 2.94, here also 2.94, up to 3 significant figure, here also 2.94, and similarly here also. But change is third and fourth places, but it is desired up to 3 significant figure. Then you can declare your answer. You have to 3 significant figure. The 80th iteration an, bn, and xn plus 1 are equal up to 3 significant figure. So you can say 2.94 is the root of the equation up to 3 significant figure. In this way, you can complete this calculation. Thank you very much.